Assalamu alaikum, welcome to Qamar MoonBoy channel, and this is a new video for you. Do like my video so that I can create more for you by clicking on this like button, and also subscribe my channel if you haven't subscribed my channel till now, and also press on the bell icon if you're not getting this notification for my channel. You will get a notification every time I upload a new video. Thank you.
In this video I'm going to show about how to load the building and do analysis using this structure. In this structure I will change the diaphragm D that is none to D1 diaphragm, and I will make it as a semi-rigid diaphragm so that I can show you what are the warnings coming in this. And similarly, just for the verification, I will show you how to clarify with the warnings and how to get rid of it and do the analysis without using any without thinking about the warnings. So these warnings are nothing but generated due to the procedure you are following while using, like you are using a diaphragm, rigid diaphragm or semi-rigid diaphragm, and loading on that diaphragm considering the while not considering the lateral loads happens to be some kind of. So let us just define the diaphragm. We'll go to the diaphragm. Here in the diaphragm we will modify this diaphragm to semi-rigid and we will press OK. Now we will apply this actually to the all the slabs diaphragm. Now we have here these all are the options, like model cases we will not take now. Just we will go for a static design. For a static design you require dead loads and live loads. As for IS 875 you have to provide the dead loads and live loads, and dead load is nothing but the self weight of the building is already taken here. You can see the self weight multiplier is 1 and here it is dead load, and the other load is nothing but the live load. The self weight multiplier will be 0. We have to provide the live load to the structure. So we will take another load as floor finishes FF, and that load will be a super dead load because this load is a superimposed load over the slab load which we have not drawn actually. If we have drawn it, then self weight multiplier will be 1. If you have not drawn anything, then the self weight multiplier will be 0. If you take a wall, that is wall load we will take here. If you draw the wall, you need not to give the wall load separately, and you can, if you have not drawn any wall, then take it as a super dead load and then give it as a self weight multiplier 0. So like this we can modify any load, and we can give the code books also related to this. We can take earthquake loads and other different kind of loads in this, so that we will show in the later. Now we'll go to load patterns, that is load cases, and we will see these to be all linear static loads because we are going to design for static, so we need to see whether it is statics or not. So here the load combination we can give a load combination that is dead load plus live load. The multiplier is 1. That one combination we will give, and another combination will be 1.5 times of dead load plus live load. So in this combination we have to give all the dead loads as a 1 and live load as a 1. We will keep this name of load combination as dead load plus live load, and linear addition we will do. And you can click on this add button, and then you can just press on the live and then floor finishes and then the wall load, and give the scale factor as 1. Press on OK. Then you can get it dead load plus live load combination. You can also modify that, and you can also add a default design combination. Just click on this and you will get a set of designs. So here we are going to design the concrete frame design. So for that it will automatically generate all the dead load and live load combinations, that is decon 1 and decon 2. It has been generated. So in this it will use the critical ultimate values, that is 1.5 times of dead loads, and here when the building is empty, and when the building is full, dead load plus live load 1.5 times. You can check by going to the modify and show load case. There is load combinations. You can see here, this is the ultimate load combination. So by this dead load plus live load and decon 2, we will design this building. So first we have to do static design, then we can do the for the. So this is construction load also. You can check while constructing what will be the load onto the building, and what is how the stepwise construction we can do in that. So now we will give the loads to the building, that is floor finishes. So we will select the floors, go to select, then we will go to properties for selecting the loads, that is slabs. We'll select the slab 200, that is the bottom slabs, and we'll give the parking loads. Here we'll give the floor finishes. We'll assign the shell loads, uniform load, and here we have to give, you can give in the dead load also, or you can give in the floor finishes also. Here in floor finishes we'll give the, because you have some mentioned separately dead load as floor finishes, so we'll replace existing load. If already some load is assigned by mistake, it will be replaced, or you can add to the previous load. So it will be there in the gravity direction. So the gravity direction here is Z direction. We can check for the loads by right clicking on the member or slab. Now we will go for another. We will select the slabs again. It's slab 125, the above load slabs. We'll select. Then we will apply for the load. We'll go to assign. Then we will assign the uniform load, that is floor finishes. Apply. Okay. Now let's select the beams over here. Go to the properties and then select the beams. Let us first select the concrete beams other than plinth beams. Will not select the plinth beams. That is 230 by 450 and 230 by 600. We will select, and we will give the wall loads on them. So for giving the wall loads, you have to subtract the beam depth also while taking the height, and then we will take the brick masonry density as 19 kilonewton per meter cube. Then we have, when we have selected, you can see all the members are selected. So we are going to deselect, and we are deselecting the stories, that is the bottom floor. Here the ground floor, this also getting selected, so we will remove this also. Here go to stories and remove the ground floor also. We will deselect all these floors. Now we have selected all the floors, beams. Now we'll give the beam wall loads wherever the walls are coming, or we can select one by one beam and we can give the wall loads. So now we will go to the loads, that is assign. Frame loads, distributed load. Will give in the gravity direction, and the load will be we need not to mention minus sign here because it is in gravity direction. So calculate the load, you will get it 5.25 for 600 mm depth of beam. We have to deduct. So by mistake I have given the loads to the dead load only, so I have to select the wall load case, then we have to give the wall load. So here you can see it is written that it is a dead load over the span of frame. Here it is comes under load pattern dead load, but we want not in dead load, but we want in within the there is wall load. So we'll select it again. Oh, before that let us go to the slab 200 and let us give the live loads. And we will assign the live load to that. Let's undo it and we will just keep the correct the wall load, then we will go for like giving the live load. That will be better. Otherwise again after completion of all the dead loads only we will give the live load. So we will select these beams once again. We'll deselect the 4 stories. Then we will go and select the distributed load, frame distributed load. We'll give it to wall load. Since we have undone it, you can see I have pressed undo, so that load from the dead load has been removed and it has been applied to the wall load. Now we will go and assign the live loads to the building. We select the shells, go to select, select the slab panels, and assign the live load to the upper slabs. We will take it as a new office building, so we will give live load as 4. For office buildings it is live load in the offices is 4, and in the corridor and the staircase it will be 5, and also you can take in the parking area to be 5. So you can check by right clicking these loads, and again select the bottom stories slabs, that is go to the properties, slab sections and slab 200, select it, and then you can apply this load to shell loads to uniform, live load as 5. So do follow the IS code for this, applying the loads for calculation. You can apply your own. Just this is a proper procedure of applying these kind of loads. Now we have applied all the loads. Now you can check these loads by using the icons above. Also you can give the plinth beam loads and the cellar floor beam loads wherever the walls are coming, so that also you can give. And you can give separately, you can give exterior wall load and interior wall load differently. By this here show loads, you can just select and see what the loads are. So here the gravity live load is 4, you can check. when you are checking for shell loads. When you go for frame loads, it will show the frame loads. Now you can see the shell load here, and floor finishes is 1.5. You can see these are two shell loads. Wall load will not be shown because you have not given it as a floor load. It is a wall load is a frame load, not a shell load. So we'll go to frame load and we'll check the wall loads. Dead load is not given, live load not given. You can check by whenever you are selecting wall load, this pop-up comes up. So here you can check all these loads has been taken. So now we will go for analysis of this model. So this is, let's come back to 3D view and let's turn it back to plan view. Then we will go for check for this model.